Hi and welcome to this weekly video. In this video I'm going to show you how to generate some kind of basic odometry using only RGB sensors, so basically a normal camera, not depth sensors, nothing. So that's something that's useful for people that we have a very simple robot and you're starting and you want some kind of odometry to know if the robot moved and fix the cases where the odometry, the wheels, isn't quite cutting it. So it's not the perfect odometry, and obviously it will work not as well as it would work a laser odometry using navigation and so on. That's why we have the courses of navigation. So I leave it in the video description if you're interested in more efficient ways of navigating. But this is a very basic and crude way that you could use to have some kind of information whether the robot is moving and in which direction. And that's it. So let me show you how. So I put myself here. Yeah. So essentially I have made this project that I leave in the video description, and I've set some instructions that you'll have to follow to make it work. The first thing is to just update in a terminal, update and install one thing that you will have to do it each time that you launch the project. And then you have to launch these commands that I'll show you how they work. But essentially what we're using is this monoslam from RG Polito. Sorry if I mispronounced. And this package it works quite well, and it's quite difficult to find a monochrome RGB only odometry that works in Robotics, so I highly recommend this one. And basically what we're doing is launching this monoslam with this config file and stating which is our RGB camera topic. So here we have in our Catkin workspace we have monoslam configure, and here we have conf cg, and essentially I didn't touch anything. Here is to adapt it to your own camera. It doesn't matter if it's simulated or not. Simulated cameras normally don't have distortions unless they are made to have them, but real cameras do have distortions, and therefore for this kind of odometry generation it's important that you generate this calibration. If you're interested how this calibration is done, please leave it in the comments below and I'll do a video about it. But basically it's using a checkerboard and moving it around, and then it auto-generates with a ROS package this configuration parameters. So it's not very difficult. Once you have it, basically you're launching it and it will capture points in space and generate some kind of odometry. So let me show you. So here I'm going to relaunch everything so you see how it's done. So the first thing is to launch our simulation. I'm using an AWS simulation of a bookstore. There we go. So if you click here, you'll get your simulation. There we go. So as you see, it's quite nice simulation with loads of details, and this is one thing. So this odometry doesn't work when the scenery, so the world, is very simple. So I tried it with a low poly world and it really didn't work, because I think it works when there's noise, when there's difference between one place and another, when there's textures in the walls, in the floor. Otherwise it really doesn't work. It really doesn't work. But for like real environments it will work. Okay, let me just set the Okay, there you go. So there we have our robot box, which is a very simple robot for this kind of tests that I made. So this is one thing. Then what we're going to do is okay, this one and this one is a static. So we're going to publish a static transform so that we basically link our robot camera to the world. Essentially, that's what we're doing. And then we're going to launch the monochrome odometry generation, which is a ROS run mono slam. There we go. And now we are going to launch our RViz to visualize the data and command vel to move it. So let's lower the speed and let's open the graphical tools. And as you can see here, we have the points, and then this is more or less the place where the robot is now, or thinks. So as you can see here, it's really, really noisy. So it thinks it's moving, which it really isn't. But you're getting some idea there of the movement at least. So that means basically that it's not moving with this kind of noise. Okay, so now I'm going to turn. Let me put this a bit smaller so we can see everything. There you go. Okay, let's go. So lower the speed and we're going to turn. There we go. So now it's trying to figure out where he is and the space. So that's basically the status of how this is done. So we could improve it, we could lower the rate. As you can see, if it's not moving, then it's not moving the model here. So it seems to kind of work. There you see that it's moving forward. So yeah, it's moving forward. Now we're doing some kind of turn and we go forwards. Then again. And as you can see here, we have some kind of points that are those points that you're seeing here. More or less, he thinks that he's moving like that. Basically, these points should be rendered in another configuration. But the most important part is this. So you're getting some kind of odometry. Of course, this needs a lot of work. Of course, this needs more debugging and this kind of stuff, but it's somewhere to start. So if you want to do some kind of only RGB navigation, this is the place to start. So you can use the Robotics that I give in the video description, and if you get to work it much better, please let me know. And that's it. So thanks a lot and see you in the next video. Bye.